Welcome to Maths Tuber. So today we are going to start with chapter number 9, that is differential equations. So if we talk about differential equations, first of all, what is a differential equation? Uh, so differential equation is basically a combination of variables along with the derivatives um and the mathematical symbols or operations, you can say. So there is one independent variable that is x, and there is a dependent variable y, right? So we just have to, for example, if we take an example here, x into dy by dx plus y equal to 0. So this kind of equation is known as where there are the variables and the derivatives also. It can be of any order. The derivative can be of any order. I have taken the example for first order derivative only, but it can be like this also: x square d cube y by dx square cube plus d square y by dx square plus x dy by dx equal to y. So it can be like this also. So these are all kind of differential equations, right? So the first topic here is um, the order and degree of a differential equation. So let us first talk about the order of a differential equation. So order is basically the highest order derivative that is used in the differential equation. Any order derivative means the highest order among all the derivatives that are used. We have to see only the highest order derivative, right? So that will become the order. There is no restriction in it. So uh, let's take some examples here. So if we talk about a differential equation that is given by x square d square y by dx square whole cube plus y dy by dx plus 1 equal to 0. Let us say this is the differential equation and we want to find its order. So as we talked about the order, it is the highest order derivative that is used in the equation. So we can see that there are two derivatives. One is dy by dx and another is d square y by dx square. So the highest order derivative is the second order derivative, right? So the order in this equation will be equal to 2. Similarly, let's take another example. D raised to power 4y by dx raised to power 4 plus x d square y by dx square plus y dy by dx equal to 0. Let us say this is the differential equation. So now the order will be equal to 4. As you can see, the highest order derivative is the fourth order derivative here. So order will be 4. So it's simple. Order is always simple. There is no restriction in it. Now let's talk about the next topic, which is called the degree of a differential equation. So degree is basically the power of the highest order derivative. So power of highest order derivative. This is known as the degree, right? So now let us take examples here. First is x dy by dx plus d square y by dx square plus y equal to 0. So if we talk about degree here, so as the definition says, power of the highest order derivative. So now if we have to find the highest order derivative, which is d square y by dx square here. And its power is basically, because there is no power on it, so we will take the power as 1 only, right? So the degree will be 1. Now, let us say we have y triple dash x y triple dash whole cube plus x square y dash square plus y equal to 0. Let us say this is the equation. Now this y dash and y triple dash represents the order of the derivative. Y dash is the first order, y triple dash is the third order derivative. So now the degree will be, as you can see, the highest order derivative is the y triple dash here, which is the third order derivative, and its power is given as 3 here. So the degree will also be 3. It is equal to the power of the highest order derivative, right? So now the topics are simple, order and degree, but there is some restrictions in the degree of the polynomial. Sorry, in the degree of the differential equations. So what is the restriction? So let's talk about that. So the degree of a differential equation is not defined if any order derivative, any order derivative, that is y dash, y double dash, y triple dash, etc., are in the functions. For example, if they are in the trigonometric functions, if they are inside log or e raised to power x or inverse trigonometric functions, so then the degree will be not defined if any of the derivative is in are in these functions. These it can be sine, cos, tan, cot, or it can be log, e raised to power x, or any inverse trigonometric function, right? So here the degree will become not defined. So let us see some examples here. So let us say, for example, first one is if we have x sine d square y by dx square plus dy by dx plus y equal to 0, right? Now the order here, there is no restriction on the order. So order will be the same. That is the highest order derivative that is there in the differential equation. So you can see the highest order derivative is d square y by dx square. So it will be 2 only. But if we talk about the degree here, since we can see sine here, so we have to check whether this sine is on the derivative or some other x or y. If it is on x or y, then there is no problem with it. But if it is, but if sine or any other function uh, is having any derivative inside it, then the degree will be not defined, as I told you, right? Now the second one is, let us say we have x square d cube y by dx cube whole square plus x log dy by dx plus y equal to 0. So now the order is 3, obviously, because the third order derivative is the highest order derivative here. And the degree, what about the degree? Um, so according to the definition, it should be 2 because the power of the highest order derivative is 2 here. But here in the next term, we can see log outside the this derivative dy by dx. So that's why. the degree will be not defined here because no derivative should be inside these functions, the listed functions that we have discussed, right? So that's why it will be not defined. Now let us take another example here. Third example. Suppose we have x y double dash q plus log y into y double dash y dash plus x into log y equal to 0. Let us say this is the function. So now let us talk about the order and degree. Order will be obviously 2 because second order derivative यहाँ पर highest है. That's why it will be 2. And degree, what about the degree? Since you can see that log is there in the equation, but log is log is having y inside it, not any derivative. So that's why if there is log x or log y or sin x or sin y, then there will be no problem. The problem is when any derivative is inside the function. So the degree will be 3 here because the power of the highest order derivative is 3, right? So this is how order and degree works. And this is the first topic that we have done already. And you can try the exercise questions, 9.1 exercise questions based on the topic. There are only 12 questions. You just have to name the degree and the order of these, right? So try them. Now let us come to the next topic, general and particular solutions of differential equations. General and particular solutions of differential equations. General and particular solution means in the general solution, whenever we solve a differential equation, we will get some arbitrary constants, right? And these arbitrary constants will be equal to its degree. What is the highest order derivative that is being used there? So based on that, there will be the number of arbitrary constants we will get. But in case of a particular solution, we will not get any arbitrary constant like A, B, C, or anything like that. We will get a particular value for it, right? So that is called a particular solution. So in the particular solution, you just have to remember that in the particular solution, there are no arbitrary constants. And in general solution, there are arbitrary constant that are equal to the order, oh, sorry, that is equal to the order of the differential equation, right? So based on that, we have exercise 9.2 here. So let's talk about. So in the exercise, we just have to verify whether the given equations are the solutions for the uh, differential equation or not, right? So for example, let us talk about the first question here. We have y equal to e raised to power x plus 1. And we have to verify whether it is a solution of double dash minus y dash equal to 0 or not. So we just have to first find out the derivatives here. So if we talk about y dash here, so it will be e raised to power x plus 1 ka derivative is 0, right? And y double dash is also e raised to power x क्योंकि e raised to power x का derivative तो हमेशा हमेशा same रहता है. So now we can put the values of y dash and y double dash in this equation. So let us take LHS, which is y double dash minus y dash, which is e raised to power x minus e raised to power x, which is equal to 0. And that is also equal to RHS. So hence we have verified the equation, right? Then next is, let us do a few more questions here. So let's do this fourth question of this. Y equal to under root 1 plus x square, and we have to verify it for y dash equal to xy upon 1 plus x square, right? So dy by dx अगर हम इसमें करते हैं, या y dash एक ही बात है, जैसे भी आप करेंगे उसकी जगह हम y dash भी लिख सकते हैं। तो अंडर रूट का करेंगे तो ये हो जाएगा 1/2 अंडर रूट 1 प्लस एक्स स्क्वायर, and into, according to the chain rule, we will do the derivative of 1 plus x square as well, which is 2x. So 2 will cancel out each other. Now we have x upon under root 1 plus x square. This is the value of y dash, right? But we want to change it to this one. So how can we do that? Either you can take RHS from here, because अगर हम y dash की जगह पुट कर भी देते हैं तो भी हमारा आंसर एग्जैक्टली नहीं आ पाएगा। नहीं तो दूसरा मेथड है, जैसे कि आप यहाँ पर देख सकते हैं कि इन दिस वन 1 प्लस एक्स स्क्वायर हमें देखने को मिल रहा है, जबकि यहाँ पर अंडर रूट 1 प्लस एक्स स्क्वायर है। तो हम इसको 1 प्लस एक्स स्क्वायर से मल्टीप्लाई एंड डिवाइड कर सकते हैं टू रिमूव द square root from the denominator. So it will become x into under root 1 plus x square upon 1 plus x square y dash हो गया, and now this under root 1 plus x square in the numerator will be replaced by y, as it was the question. So x y upon 1 plus x square, and this is how we have verified the equation, right? Now let us do one more question. Let us do the sixth question. Y equal to x sine x. So, and we have to verify here x y dash equal to y plus x under root x square minus y square, right? So now, if we talk about y dash first, we will have to apply the product rule. So x cos x plus sine x into 1, right? Now, let us take LHS first. So it is x y dash, that is x into x cos x plus sine x. And if we multiply them, x square cos x plus x sine x. So that's it. I don't think we can do further. So we'll take RHS now. So it is y plus x under root x square minus y square. So now we can replace all the y's here. X sine x plus x under root x square minus x square sine square x sine x plus x under root x square will be common, it will become 1 minus sine square x, and that is cos square x, right? And if we take this x sine x plus x under root x square cos square x, if we take this outside the root, you will get x square cos x, because there is one x in outside, and this x will also come outside, so it will become x square. So now you can see the answers are matching, therefore LHS is equal to RHS, and hence we have showed that or verified that the given equation is a solution of the differential equation, right? Now, let us do the last question from this exercise. That is the ninth question. This is x plus y equal to tan inverse y, and we have to verify the solution for y square y dash plus y square plus 1 equal to 0. So now let us take the derivative here. 1 plus y dash is equal to tan inverse का होता है 1 plus 1 upon 1 plus y square into y dash. And take y dash, all the y dash on one side. So you'll get y dash common ले लेंगे तो ये हो जाएगा 1 plus y square minus 1. 1 minus 1 minus y square 1 plus y square into y dash 1 1 cancel हो गया. So y dash will come out to be 1 plus y square upon minus y square. Right. So now take LHS. LHS is y square y dash plus y square plus 1. This is y square into y dash की value is 1 plus y square upon minus y square plus y square minus plus 1. So y square will get cancelled, and now this minus will go with the numerator. So it will change all the signs here. Minus 1 minus y square plus y square plus 1. So you can see all of them will cancel out each other. So the answer is 0, which is equal to RHS and hence verified. Right. So this is a very simple topic where we know the derivatives, like right. We already know the rules of the derivative. We have to derivate it uh, according to the given differential equation, and then just put the values in LHS and RHS. You'll get the solution. I hope this is clear. And the 11th and 12th question from this exercise are the multiple choice question, where we have already discussed that the number of arbitrary solution, sorry, the arbitrary constant, the number of arbitrary constants in the solution of a differential equation are equal to its uh, order, right? For example, in 11th question, it is given the differential equation is of fourth order. So if it is of fourth order, then the number of arbitrary constant in the general solution will be 4. And in the 12th question, it is given that the differential equation is of third order, but we want to find out how many arbitrary constants will be there in its particular solution. So in the particular solution, as I told earlier, there are no arbitrary constant. So the number of arbitrary constant in the particular solution will be 0, right? So D option will be answer for both 11th and 12th questions. Now, the most important topics starts from here. That is the method of solving first order, first degree differential equations. Right. First order means we have only one order and one degree, which means there will be no power on dy by dx. Right. Solutions of first order and first degree differential equations. So there are three ways by which we can solve these types of differential equation. The first one we are going to talk about is variable separable method. Basically, we are solving it by separating the variables, right? So we'll discuss it in detail. The second one is known as homogeneous equations. So homogeneous differential equations. And the third one is first order differential equation. So we have three different methods to find out, and the most important means all are important, but just a second. We have this name will be linear differential equation actually. Uh, this is linear differential equation, right? So all these methods are important because any question can come out of these three methods. So we just have to find out first which method will be used because all three methods are different from each other, and the questions done by them will also differ according to their according to the equations. Actually, we have to apply them. So first of all, we have to figure out which one to be which method to be applied, right? So let's talk about variable separable first. So variable separable method is used when we can easily separate the variables in a differential equation. If we are not able to separate the variables accordingly, then we have to go for the second or third method, and we'll talk about them later. So first is called variable separable method. So let us understand this with the help of an example, right? So here we have an example dy by dx minus y equal to cos x. So there are two variables y and x. Let's not talk about dy by dx here. We will only talk about y and cos x, right? So first of all, we have to check whether we can easily separate them or not. So here you can see you cannot separate both y and cos x, right? Because we have to take this dy by dx to the side of the variable x and dy to the side of variable y. So here I don't think we can do that because if we take y to the other side, then also x and y will be on the same side. Then we cannot take dy by dx to their respective variables, right? So let's take another example for it. Here we cannot apply this method in this example. So let's take another example. We have dy by dx equal to x plus 1 upon 2 minus y. So now um, we have to separate them in such a way that dx should be with the variable x and dy should be with the variable y. So if we cross multiply them, you can see you can easily separate the variables like 2 minus y into dy, and this dx will come on the right hand side. So x plus 1 into dx, right? Now you can see all the y's are on the one side and all the x are on the same side, right? And now we have to integrate both the sides. Obviously, because the differential equations have derivatives in it. So to solve them, we have to use antiderivative, which is integration. So we have to integrate both the side. We will put the symbol of integration. And if we can easily do the integration, then it's fine. Otherwise, we have to apply some rules that we have discussed earlier, right? In integrals. So here this will be 2y minus y square upon 2 is equal to x square upon 2 plus x plus c. And this constant of integration will come on one of the sides, any one of the sides, right? Usually we do it on the right hand side only. So You can understand that easily. And also, one more thing, if there is a possibility of rearranging this 2 here, like if we multiply the whole equation by 2, so it will become 4y minus y square equal to x square plus 2x plus 2c. So what we will do is we will take C1 this one as C1 जो हमने पहले C लिया था उसको हम C1 कर देंगे, and now this 2C will become C here, 2C1 will become C, and you can take all these variables to one side also. That's your choice. So this will become C, and this is the solution of this equation, final solution, right? So this is how we can do this. So this was a very simple question. Let us come to the exercise questions, which is exercise 9.3. There is nothing new in this chapter. We just have to learn all the integrations, the rules of integrations. So let's talk about the first question, which is dy by dx is equal to 1 minus cos x upon 1 plus cos x. So you can see here, there is no variable y here. There is only x variable, right? Cos x है दोनों side. So what we are going to do is we will take this dx to the other side along with the variable x. So it is 1 minus cos x upon 1 plus cos x into dx. And then integrate both the sides. So dy का जो integration है, that will be y obviously. And here we have to work. So 1 minus cos x. Uh, so for these kind of equations, we have half angle formulae that we have discussed in inverse trigonometry also. 1 minus cos x can be written as uh, I think 2 sine square x by 2, and this is 2 cos square x by 2, right? So this will get cancelled. And one more thing, हम अभी इसमें dy का इंटीग्रेशन नहीं करेंगे. जब हमें करना होगा तो हम पूरी इक्वेशन का एक साथ ही करेंगे so that we can take the constant of integration on one side. The integration dy, this will be tan square x by 2. Now we don't have any integration for tan square x, but we have it for sec square. So we'll convert this. It will be sec square x by 2 minus 1 dx. Now you can integrate it. This will be y. Sec square x का होता है tan x by 2, और 2 आ गया जाएगा बिकॉज उसका डेरिवेटिव 1/2 होगा. वैसे तो मैं लिख देता हूँ यहाँ पर, the derivative of the linear polynomial will be in the denominator. So 1/2 denominator में आएगा तो ये 2 जो है वो ऊपर आ जाएगा, minus x plus c. So now this will be y equal to 2 tan x by 2 minus x plus c. And this will be the solution, right? Okay, so now let's come to another question. So let's do the question number 4th here. So this is x square x into tan y dx plus sec square y tan x dy equal to 0. First of all, we have to separate the variables. So we'll take dx and dy to other sides. This will become minus x square y tan x dy. So take all the y's to one side. अब जहां पर ये dy और dx न्यूमरेटर में होंगे हम उन्हें वहीं लेके जा सकते हैं. सो माइनस एक्स स्क्वायर वाई अपॉन tan y इंटू डी वाई, ये तो यहाँ हो गया. और ऐसे ही ये सेक्स स्क्वायर एक्स डी एक्स अपॉन tan x, and now integrate both the sides. So we know that tan x का integration is sec square x and tan y का integration is also sec square y. Not integration, sorry, derivatives. So we'll put them. Put tan x is equal to u and tan y equal to v. So this will become sec square x dx is equal to du and sec square y dy equal to dv, right? Now this will become u du is equal to minus v dv. So this will be u square upon 2, u square upon 2 equal to minus v square upon 2 plus c. You can remove this 2 by multiplying the whole equation. So take this as c1, u square equal to minus v square plus 2c1. U is tan square x equal to minus tan square y plus c, where c is 2c1. Tan square x plus tan square y is equal to c, and that will be the final answer, right? Let us try one more question from this exercise. This one is 10th question. Let us try the 10th question. E raised to power x tan y x plus 1 minus e raised to power x x square y dy equal to 0. So now what we have is okay, so now we have to again separate the variables. So e raised to power x tan y dx equal to 1 minus e raised to power x x square y dy and minus, right? So e raised to power x upon e raised to power x minus 1. We can adjust this minus with 1 minus e raised to power x, so the signs will change. And here we can take sec square y upon tan y dy and then integrate both the sides. So here what you can do is you can take e raised to power x is equal to u. So e raised to power x dx is equal to du. And here you can put tan y as v. So sec square y dy equal to dv, right? Um, I think I made a mistake here in this question, fourth question. So let me just correct it. Here we had taken tan x as u. So it will be du upon u is equal to minus dv upon v. Now du upon u is log u and dv upon v is log v. So this whole will change here. This is log u equal to minus log v plus log c. Whenever there is log in the whole equation, then you can take the constant as log c only, right? It will be easier because we have to remove this log also. So, but this is in case if all the terms of the equation are having log. Otherwise, if there is one term which is not having log, then we don't have to write log c here. So now put the values. This was tan x, log tan x minus log tan y is equal to logs plus log c. So this log tan y will come to this side. It will become plus log tan x plus log tan y is equal to log c. And this will be log a plus log b is log a into b. So it is log tan x into tan y equal to log c. Now, because we have log both the sides, so we can remove it very easily. Tan x into tan y will be equal to c, and this will be your equation, right? So this is how we have to do it. Now let us come to this question. As we were discussing, in this question also we have to do the same thing. Dx, it will be du upon u and dv upon v. Du upon u plus, sorry, equal to dv upon v. And this will be, no, we have to integrate it. Du upon u is log u equal to log v plus log c, as I told you. Log u minus log v is equal to log c. And now you can put the values of u and v also, which is e raised to power x minus 1. And v is tan y. So log tan y हो जाएगा ये. Now this will be log c. So now log a minus log b is log a upon b, which is e raised to power x minus 1 into tan y is equal to log c. And now you can see log is on both the sides, so you can easily remove them. So it is e raised to power x minus 1 into tan y is equal to c. E raised to power x minus 1 is equal to c into tan y. This will be the answer, right? I hope this is clear to everyone. So I think that's it for this class. So I will make another video based on this. Okay.